Hello everyone, we are from Group 7. We'll present our assignment today, which is Palm Oil Based Surfactant Production. Our group members are Ermey binti Abdullah, Maimunah binti Villiamor, Nur Fadzilah binti Usman, Nur Imanina binti Mohd Si, and Nurfazziera binti Majid.
Hello everyone, I'm Maimunah binti Villiamor. I'll be presenting the introductions. Basically, palm oil based surfactant is an oleochemical that can be produced from epoxidized methyl ester from palm oil through sulfonations of esters. It's a molecule which has hydrophilic and hydrophobic groups in one structure. In addition, surfactants reduce interfacial tensions between fluid and fluid, fluid and wax, and fluid and hydrocarbon to increase the permeability of formations in an effort to increase the production rate. Theoretically, all types of surfactants can be synthesized from palm oil because of its physicochemical properties and fatty acid compositions, as shown in Table 1 and Table 2, which fits the requirements. Moving on to the process descriptions. Basically, palm oil based surfactant, which specifically is alpha-sulfonated ethyl ester, was synthesized from palm oil via trans-esterification process. In synthesis method esterification reactions, first we have to weigh the palm oil and polyethylene glycol 600 in a stoichiometric amounts, then mix it with constant stirring, and the reaction mixture is heated at a temperature of around 60 degrees Celsius for about 30 minutes. Second, add lipase subsequently to the reaction mixture of 10% of starting material and consistently stir the reaction mixture for 48 hours. In between, monitor the progress of the reaction by checking the TLC, which is the thin layer chromatography in the mixture of petroleum ethyl acetate as a mobile phase. Then filter off the excess lipase and remove the fatty acid residue by washing with a mixture of diethyl ether and a small amount of sodium bicarbonate solutions. After that, the lipase catalyzes esterification of palm oil in the presence of polyethylene glycol adds in conversions of free fatty acids present in oil into ester. Then evaporate the remaining solutions under vacuum in order to obtain a light yellow semi-viscous liquid. For the sulfonation reactions, use the product obtained in the esterification reactions to synthesize the desired product by sulfonation of palm oil ethyl ester. In these reactions, add the chlorosulfonic acid to pyridine, then carry out the reactions in an ice bath under constant stirring for 30 minutes. After that, the reactions mixture was heated to 60 degrees Celsius till a clear solution was obtained. Then, quench the solutions with a saturated solutions of sodium carbonate and sodium bicarbonate in a separating funnel. Then, pour the normal butanol into the separating funnel to dissolve the components which remain unreacted in the organic layer to obtain the desired product in aqueous layer and heat it to a temperature of 120 degrees Celsius to remove water and pyridine from desired sulfonated product. Then, remove the organic impurities from the final sulfonated product by washing it with petroleum ether twice. Vacuum drying the product at 60 degrees Celsius for 24 hours in order to obtain the final wet solid product, which was characterized with FTIR and GC. Basically, this is the reaction scheme for the synthesis of alpha-sulfonated ethyl ester, which is the desired product.
Hi, my name is Nur Imanina binti Mohd Si, and I would like to explain about mass transfer, heat transfer, and fluid mechanics. In this section, I will share in general about the production of palm oil, not about the palm oil based surfactant, and the detailed explanation is in our report. Mass transfer is simply defined as a natural tendency of mass to be transferred from a higher concentration region to the lower concentration region. Based on the research, they use these equations to find the mass transfer of oil palm fruit mesocarp by calculating the change rate of water and oil concentration within the oil palm fruit. The first graph shows the increment of water concentration, meanwhile the second graph shows the decrease of oil concentration in mesocarp. To sum up, mass transfer is occurred in the production of palm oil, such as in the digestion phase where water diffuses into fruit mesh whereas the oil is released. Briefly, heat transfer is the flow of heat or thermal energy due to the temperature difference. It can happen either by convection, conduction, or radiation. But in the production of palm oil based on the research conducted by Yunus et al. 2015, heat transfer occurred where convection is from water to mesocarp, meanwhile conduction happens within the mesocarp. Basically, heat transfer occurred throughout the mesocarp, shell and kernel of the oil palm fruit. So, based on the graph here, it shows the result of the temperature profile in the inner mesocarp indicating the heat transfer occurrence, where the data was obtained by calculating it using these equations. For the fluid mechanics in the production of palm oil, according to Aziz et al. 2016, in their research about computational fluid dynamic analysis of co-firing of palm kernel shell and coal, they use these equations, which simply is about kinetic energy and dissipation rate of turbulence, in order to measure and calculate the swirling combustion flows in the manufacturing of palm oil.
Hello to everyone, my name is Nurfazziera binti Usman. So for today, I will present the chemical engineering process equipment and calculations. So since Mai has mentioned before about the alpha sulfonate alkyl ester, alpha SEE surfactant, thus in this part I have specified the surfactant, which is also alpha SEE, in order to produce efficiently a quality product and environmentally appropriate. Generally, flooding tests we use with the surfactant slugs at various alpha SEE concentrations in order to achieve appropriate percentage, that is about 25% to 27% of additional oil recoveries after conventional flooding. Moreover, for the evaluation of the efficacy of the synthesized surfactant alpha SEE, sandpack flood tests we use to increase oil recovery after conventional water flooding. As you can see in the screen, this is a schematic of the experimental configuration for flood tests in the sandpack method. It consists of 4 parts. Those are co-holder, displacement pump, chemical solution cylinder for crude oil, brine, which is sodium chloride, and surfactant solution, and finally fractional collector. In the alpha SEE test, it was flooded with the brine and the absolute permeability was calculated from the flow rate and pressure drop through sandpack using the Dorsey's law equation. Generally, the law of Dorsey was used to measure the efficient oil permeability and the efficient water permeability at irreducible water saturation and residual oil saturation. As you can see in the diagram, flooding tests with the injection of alpha SEE surfactant slugs at 3 different concentrations were carried out in the sample, which are A, B, and C. There is a large amount of surfactant absorbed on the rock surface during surfactant flooding. In order to account for this absorption losses, flooding tests are also conducted at concentration higher than CMC critical Michel concentration value, which is 8,000 parts per million with surfactant slugs. Just to let you know, CMC critical Michel concentration is a surfactant concentration in the bulk phase above which aggregates of molecule of surfactants called Michels start to form. The CMC is determined with a tensiometer by measuring the surface tension of a concentration series. Flooding tests indicate additional recoveries of 25.8, 26.1, and 26.3% OOIP original oil in place by injecting various surfactant slugs with concentration of 8,000, 10,000, 12,000 parts per million respectively after traditional water flooding for 2% brine salinity sandpack system. There are several measurements need to be taken in order to design the surfactant slug with optimum surfactant concentration while preparing for surfactant flooding in the chemical enhanced oil recovery. Essentially, optimum surfactant concentration depends on the surfactant CMC, surfactant adsorption on the reservoir rock, salt tolerance, and interfacial activity at the oil aqueous interface. For the alpha SEE surfactant interfacial properties, overall, the synthesis surfactant CMC is found at 27 degrees Celsius to be 8,000 parts per million. In the crude oil aqueous solution interface at CMC, an ultra-low IFT of 1.17 exponent -2 millinewton per meter is observed. Under optimum salinity conditions, 2% sodium chloride at CMC, the IFT value is further reduced to 8.3 exponent -3 millinewton per meter. IFT decreased to very low values with the addition of organic alkali, monoethanolamine, MEA, and obtained a minimum value of 6.81 exponent -3 millinewton per meter at pH 12 for the alkali surfactant system at CMC. Next, for the studies on the wettability, the changing on composition of both quartz and carbonate rock surfaces from oil wet to water wet, the surfactant demonstrates strong wetting characteristic. For the salinity of contact angle, at first contact angle values are found to decrease with surfactant concentration down to CMC. After that, it begins to increase. The effect of the salt addition shows a much lower reduction in the contact angle compared to that of pure surfactant solutions.
For the mass balance, this flowchart is based on the production of palm oil based surfactant. We have 5 unknowns here, which is M1, M2, M3, M4, and M5. Simply, when doing the mass balance calculation, we will get 52 kg of desired product. The initial reactants, such as 0.9 kg of FEM, 0.098 kg of pentyl ethylene, and 0.002 kg of lipase. All these substances are the required compounds in order to produce palm oil-based surfactant. For the energy balance, this process is in a closed system where no mass crosses between the system boundary.
In oil palm production process, many problems causing reduced production and environmental pollution detected. To overcome these problems, palm oil-based surfactants the best to use. First is for stimulation, where the oil will undergo repayment to increase its permeability as well as production rate by the injection of surfactants. During this process, reservoir rocks will soak in a surfactant and be in penetration process. This can improve the permeability and well productivity. Second is as asphaltene dissolver. Asphaltene is a molecular substance that dark in color which present in most petroleum materials. Asphaltene adsorption causes issues like pipeline falling during crude oil processing. We can use solvent to dissolve asphaltene but only able to remove 50% asphaltene deposit compared to addition of surfactant. Third is wax dissolver. At lower temperature under oil pouring point, the wax is formed around tubing and production pipe that causing a decreasing rate production. Thus, surfactant plays an important role in increasing oil production in highly depleted wells by reducing interfacial tension, altering workability of rocks, and cleaning oil wells from organic sediment. Dissolving wax is more effective by using solvent plus surfactant than by using solvent only. Next is as emulsion breaker. Is when two or more liquids that cannot mix will create an emulsion when one is added to the other. Emulsion can cause severe problems in distillation columns, heat exchanger, and reboiler. In this case, surfactant will have various of contaminants and additive is stabilize the emulsion from upstream operation. Surfactant also important for well cleaning. Surfactant can be developed as a cleaning agent for holes of perforation well, pipelines, and oil production equipment from blocking oil remains so that oil production process can be optimum. Other than that, is functioning well for sludge breaker. The oil sludge will not be filtered because the solid content is too high that causes clogging. By using surfactant, organic pollutant can be removed in a fast and cost-effective way. Surfactant characteristic enhance its removal of organic pollutant. Lastly is chemical flooding. Chemical flooding is a method used to obtain more amount of oil after the reduction of primary production process by using natural energy originating from the reservoir itself. Chemical flooding is obtaining oil by injecting material from outside the reservoir.
Hi everyone, my name is Ermey binti Abdullah and I would like to share about environmental impact. First, for palm oil based surfactant production, methyl ester that were used as feedstock contributes significant environmental impact. This is due to the production and activities at the upstream level were included in the analysis, that is refined bleach deodorized palm stearin. This is followed by steam, where the impact was due to the utilization of fossil material to produce steam, which in this case, electricity was used to produce steam for the plant boiler. Lastly is greenhouse gas emissions from palm oil cultivation and initial processing, which is derived from two main sources. First one is land use change with additional emissions if fire is used to clear land for cultivations, and the second one is plantation and mill activities. Next is about sustainability solutions for the environmental impact that I have stated before. First, Environmental Management System (EMS) will be developed to enhance the operations of each facility and to reinforce the readiness for emergency response, also to increase the overall environmental performance. Second is diversifying energy supply and reducing dependence on import fuels, generating energy that produces no greenhouse gas emissions (GHG) from fossil fuels and reduce some type of air pollution. Next is reducing energy use can decrease the GHG as well. Last but not least, there are global targets for GHG emissions to be set if the palm oil industry is to excel. Being proactive, the industry has started in its journey on GHG emission reduction. In conclusion, the goal of this study on palm oil-based detergent production has been accomplished. There are numerous applications of palm oil-based surfactants such as chemical flooding, stimulation, and so on. In any case, this research shows how to apply the basic principles in the fundamental of the chemical process, such as mass transfer, heat transfer, and fluid mechanics, even on how to determine the detailed requirements using chemical engineering calculations, such as mass balance and energy balance. Next point is to propose an engineering approach to the problem related to the process. Nevertheless, overcome the environmental impact with sustainability solutions such as implementing a new environmental management system and reducing energy use.